We have three working designs for our submarine. The first of which is the winged design, which has one main cylinder with two pods or wings on either side. This increases roll stability and slightly improves capabilities for stereoscopic vision. However, it makes it slightly more difficult to carry and is kind of the mid-range design. Our second design is the two-body, contains two cylinders that are connected. This has best capabilities for stereoscopic vision, however it is the worst surface area and has the least ideal flow dynamics. Our final design and our current working design is the one-cylinder design, which contains no pods to either side and is controlled entirely through hulls. It has no roll stability, which is a bit unfortunate. However, we feel that roll stability isn't really necessary, and it does have the best flow dynamics and is the easiest to transport. All three of these designs will be connected to a float on the surface, which will somewhat resemble a dock, which will maintain the power source, the batteries, as well as a wireless receiver and the tether.
In this project, we looked into using brush motors first off, and they weren't very reliable and we weren't sure how well they do underwater. So we moved on to brushless motors, which we know to be more waterproof. And to control them, we're using electronic speed controllers. And to do this, we had to program it in Java, and we're using Servo Blaster on the Pi, which takes the inputs from Java and our Xbox controller and converts them into small amounts of voltage, which then change the magnetic fields in the motor so they spin at different speeds.
So in our sub, we're going to use an IMU, which is an inertial measurement unit. We're going to put it in the sub, and it's going to feed back numbers on yaw, pitch, and roll. Those we're going to put into a Java program that will show us a 3D perspective of the sub using a 3D library called LWJGL, the Lightweight Java Gaming Library. This will give us another perspective on our sub, and will also allow us to do station keeping so that we can tell the sub to just sit in one place, and if it is buffeted or rolled by anything, it can adjust itself. So what we're going to do is we're going to have this IMU on the sub. It's going to connect through an Arduino to our Raspberry Pi, and that will send the numbers through a socket server back to the program on our operating control unit.
Alright, so on the submersible we're going to be using microcontrollers such as the Arduino Uno right here, and we're going to be using these and their capabilities to do everything from temperature sensors to depth sensors to moving servos, and we're going to be connecting them directly to the Raspberry Pi either with I2C connection or just a serial cable. And from that we will be able to get data such as temperature and display it through Java. You can see in the video right here that we're just showing a quick Arduino sketch of a temperature sensor running, and we're reading it through Java. And we'll like we're doing everything, all the other software, we're going to be running all the microcontrollers through Java. So here, this is just a quick example of that working.